Good morning, guys. For today, we are tasked to find the IE, VE, VB, VC overall voltage gain, which is VO over VI, assuming that IC is equal to IE, and determine the output collector voltage of this circuit. So first, to find the DC equivalent of the circuit, we must turn off the capacitors from the main circuit, which is the C1, C2, and C3. So the equivalent DC equivalent circuit will be this. So to find the IE, IC, VE, VB, and VC, first we must solve for the RTH and VTH by using the dividends formula. So RTH, dividends resistance, is equal to R1 multiplied by R2 over R1 plus R2. So RTH is equal to 8.25 kilo ohms. And for the dividends voltage, so it's equal to resistance 2 over resistance 1 plus resistance 2 multiplied by VCC. So VTH is equal to 1.75 volts. And for the IE, dividends voltage minus base emitter voltage over emitter resistance plus dividend resistance divided by the beta DC. So IE is equal to 1.06 milliamperes. So since we assume that IC is equal to IE, so IC is also equal to 1.06 milliamperes. And for the emitter voltage, IF multiplied by resistance E1 plus resistance E2, so VE is equal to 1 volt. For the base voltage is equal to emitter voltage plus 0.7 volts, so 1 volt plus 0.7 volt is equal to 1.7 volts. So for the VC collector voltage is equal to VCC minus IC multiplied by RC. So 10 volts minus 1.06 milliamperes multiplied by 4.7 kilo ohms. So collector voltage is equal to 5.02 volts. So that's it for the DC equivalent of the circuit. So moving on to the AC. In AC equivalent circuit, to find the equivalent AC circuit, first we must short circuit the collector, the C3 to the main circuit. So first you must find RE. So RE is equal to 25 millivolts over IE. So 25 millivolts over 1.6 milliamperes. So RE is equal to 23.6 ohms. And for the resistance in total, R in total is equal to R1 parallel by R2 parallel by resistance in base. So first we must find resistance in base. So resistance in base is equal to beta AC, which is 175, then multiplied by RE plus RE1. So resistance in base is equal to 86.5 kilo ohms. So in resistance, we now can find the resistance in total. So 47 kilo ohms parallel by 10 kilo ohms parallel by the resistance in base, which is 86.5 kilo ohms. So resistance in total is equal to 7.53 kilo ohms. Then first you must solve for the attenuation from source to base. So attenuation is equal to voltage from source over voltage from VB, so is equal to RS plus R in total over R in total. So 600 ohms plus 7.53 kilo ohms over 7.53 kilo ohms, so the attenuation is equal to 1.08. And for the RC is equal to RC multiplied by RL over RC plus RL. So 4.7 kilo ohms multiplied by 47 kilo ohms over 4.7 kilo ohms plus 47 kilo ohms. So RC is equal to 4.27 kilo ohms. And for the last, you must solve for the voltage gain. So voltage gain is equal to AV is equal to RC over RE1. So RC is equal to 4.27 kilo ohms, then RE over RE, which is equal to 470 ohms. So voltage gain AV is equal to 9.09. So that's it, guys. Thank you.